what can us humans do to the Earth all on our own? I mean, there are more than 7 billion of us now. What if we all got together in one place and jumped? Well, what would that even look like? Interestingly, if you took the entire human population of Earth and had them all live in one place with the same density that people live in New York City, you could fit everyone, all of us, into the state of Texas. But that's living, not standing around in a crowd, which is how we would probably want to do the jump. If every single person alive right now on Earth stood shoulder to shoulder, you could fit all of us into the city of Los Angeles. It would be an incredible sight to behold, a mere 500 square miles containing every single person on Earth.
Okay, how are we all? Got my voice back a little bit. Here we go again with more lies from vsause. If you notice what he said here in the beginning, apparently we're overpopulated. That's the big thing, climate change and all that. Look at how many people there actually are. Well, he's not just saying America, he's talking about the whole world, all in that one spot. Wow, that's pretty amazing. Like, that is, I didn't know that. That's some pretty cool information.
Okay, so then we jump. What happens? Unfortunately, not much. I mean, we're all awesome people here on Earth, but our collective mass compared to the mass of the entire Earth, it's like nothing. In fact, dot physics calculated that if all of us were to get together in one location and all jump 30 centimeters into the air at the exact same time, we would push Earth away from us a tiny amount. Earth would only move away from us about 1/100th of the width of a single hydrogen atom. And here's another thing. Because we are all jumping and then going back to where we started, Earth is just going to move back to where it started.
What? No, it's not. You just said if everyone jumps, then those guys did the physics and worked out that we're going to push the Earth away by that little tiny amount that you said. Okay, fair enough, I'll give you that, right? But then it's going to come back because we're going to return to where we... Are we going to attract the Earth back towards us, are we? No, we're going to... When we land, we're going to push it again. So pushing away would push it away, like you just said, and landing would push it away. And, well, physics would say it'd be the same amount as we pushed, wouldn't it? So it'd... Wow. That... just wrong. That's not physics. That wasn't physics at all, mate. Sorry, but it just is not physics. Okay, next. There's a bit at the end that I really want to talk about.
So our big jump won't be able to change Earth's position in space, but come on, 7 billion people all jumping together, that's got to be able to cause some sort of seismic activity, right? So let's say you have a lot of people all together in one place, and you have them all jump on 1, 2, 3. Did you feel that? Well, the BBC did this with 50,000 people and discovered that 1.5 kilometers away, it only registered as a 0.6 on the Richter scale. You would need 7 million times more people than even live on Earth right now to jump at once to recreate the earthquake that recently happened in Japan. So, even though we're all awesome, compared to the size of the Earth, we're not much. But don't get too discouraged. Our collective jump would contain a lot of energy. The Straight Dope calculated that even if only the people who lived in China got together and jumped, their jump would be the equivalent of 500 tons of TNT. Of course, 500 tons of TNT doesn't do much to an Earth that weighs 6 sextillion 588 quintillion tons. To make yourself feel more powerful, pick a card. I've got 10 of them.
Can anybody guess which card he's gonna pick?
Choose this one.
I bet you can.
Boom. Congratulations. We have just decimated this deck of cards. Why? Well, because technically, decimate does not mean obliterate completely. Don't do so well on it, you only get 10%. Well, sure, that's an F, but by getting 10% of them right, you decimated that quiz. And And since we've been talking about crowds, let's talk about YouTube crowds, YouTube audiences, that view count that you see at the bottom of every video, and get some perspective on it. We'll begin with Dunbar's number. It's an estimation of the maximum number of people we can have stable social relationships with at a given moment, and it's based on the size of our neocortex. These aren't just acquaintances, these are people you have social contact with, a network where you know how everyone relates to everyone else, and the number is usually given to be somewhere between 100 and 230, which means that when a YouTube video receives more than 230 views from different people, more people have seen that video than you could ever realistically hope to know well at a given moment. If a video has more than 100,000 views from different people, more people have seen that video than you will ever meet in your life. And by meet, I mean shake hands with, learn their name, talk to them for a bit. I mean, think of it this way. You and me, we're only statistically expected to live around 28,470 days. So even if you were to meet someone, 2-3 people every day of your life, including when you were a baby, you still wouldn't meet as many people as have seen that YouTube video with 100,000 views. But keep this in mind. Even though you, or even a large group of us, can't do much to change Earth's location or rotation, we can affect it a little bit. Newton's third law guarantees this. If you weigh 150 pounds, the Earth is pulling you down with a force of 150 pounds, but you are also pulling up on the Earth with a force of 150 pounds. If you fall 3 meters, the Earth has pulled you down 3 meters, but you have also exerted a equal and opposite force on the Earth. Of course, it's a lot bigger. So if you fall 3 meters, you pull the Earth up about 1/1000th of the width of a proton, which ain't bad.
Okay, there's the part I wanted. So you all heard him say that. I'll just get him to repeat it to make sure you all heard what he said. And then I'll show you how they change the science to fit.
Newton's third law guarantees this. If you weigh 150 pounds, the Earth is pulling you down with a force of 150 pounds, but you are also pulling up on the Earth with a force of 150 pounds. If the Earth really is spinning so quickly, why can't we feel it? Why doesn't the Earth's rotation make us dizzy? Well, lucky for us, the change in velocity is just too gradual. The Earth is too huge. It's like driving in a car that takes 6 hours and 6,000 miles to make one left turn. It's not sudden enough to register with our senses. But that change in velocity is real, and it makes us weigh less because of inertia. On our spinning planet, your velocity is constantly changing, but always tangential to the circular path you are being dragged along. Now, because inertia is a property of matter, which includes your body, without a force acting upon us, we would slowly leave the surface of Earth. Luckily, the Earth is exerting a force on us, a center-seeking centripetal force delivered by gravity. The centripetal force required to keep you along a circular path with Earth is subtracted from Earth's total gravitational pull on you. The remaining force simply pushes you down toward the center of the Earth. It gives you weight. At the equator, if the Earth didn't spin and no centripetal force was required to keep you with the Earth, you would weigh 0.3% more than you currently do.
So, how can this be? 1 minute you weigh 150 pounds and you're pulling away 150 pounds. So that's the spin, pulling you up. So if you travel to the center where the North Pole is and it's not spinning there, so you're taking on the whole of the gravity. You would feel all of gravity. Do you know what I mean? That 150 or whatever you weigh, he said, it's equal apparently. What you weigh being pulled down by gravity is the same as what you're being pulled up. Well, yeah, that's strange. You'd need more spin to hold to make something heavier fly off of something that's being held there by a force like gravity or magnetism. You need a lot more force, a lot more spinning force to fly it off. So that's not true. But now you're saying...
At the equator, if the Earth didn't spin and no centripetal force was required to keep you with the Earth, you would weigh 0.3% more than you currently do.
Yeah, so this is what I've been saying all along. If you're moving at that speed at the equator and the gravity is holding you down, pulling you to the earth, stopping you from flying off of the equator. I know it sounds silly because it is. Sit down, sit. Good boy. Yeah, so if you're at the equator and you're spinning at 1,038 miles an hour, you travel to the equator, to the North Pole, or the South Pole, or whatever, on your globe, it's not moving very fast. So there's no outward force, there's no centrifugal force, there's no outward force pulling you out. But there has to be at least enough force of gravity at the equator holding you down. So there has to be at least your weight of gravity, at least the amount of gravity to hold your weight down. So if you travel to the North Pole, you'd weigh a lot more because it's not moving. Well, then the gravity would take over, that outward force would no longer exist, and gravity would pull you down by the amount your weight is. So you would weigh twice as much and you would feel it. So I wouldn't be worried about trying to figure out whether the earth is flat. You'd be the one who'd be flat. So this is what I mean, right? These guys, they just make it up as they go. Like he said before that 150 pounds is you're pulling the earth up by that much. Like, I don't get that, okay? Because the amount you weigh isn't your gravitational field, is it? We know that. Anyway, so yeah, that's a little bit of just, I don't know where they get that idea from at all. But people do believe it, and that's the problem. And we need to just keep waking people up, guys, slowly. But if you find something that seems to work better than most things, then yeah, use it. And I'll be back with some more Misuse from the Globe next time. See yas.